going to start now? All right, we're good to go? All right. All right, today we're going to talk about AI-driven threat modeling. So, to introduce ourselves, what is threat modeling? Why does it matter? Threat modeling challenges. Okay, that's better? All right, sorry about that. Okay, we're gonna skip the demo because our demo relied on Wi-Fi, but we do have artifact that we can produce and we can demonstrate. So who are we? I'm Srdan Reljic. I work for IBM Consulting, associate partner. I do big programs of modernization, migration to the cloud or anywhere else. I'm also executive architect. And Raj, you want to introduce yourself?
Yeah, my name is Raj. I'm the senior customer success engineer. So I'm working for Palo Alto Networks.
Palo Alto? Yep, that's the company to work for, right? So we have our LinkedIn's there if anybody wants to get more information about what we're trying to do here. So not everybody is familiar with threat modeling. Most people here are because we're all in security, right? So it's a systematic methodology identifying, evaluating, mitigating security risks within the system. There was several frameworks. This is not an exhaustive list, but these are most popular ones, tried and MITRE ATT&CK. So this is a little example of what tiny part of threat modeling looks like as an artifact. So what we were thinking is we were like, so this is a diagram, right? It's a context diagram, and why don't we, why don't we actually, the diagram is just a logical representation of the infrastructure that's been stood up. And what actually stands up the infrastructure is infrastructure as code these days, right? So we were thinking, why can't we just generate a threat model based on Terraform that you can pass to it and it will generate your threat model. So that's how we sort of started thinking about this. So I'm not going to get too much into reading off the slide and what Stride is. I'm sure these will be available or they can be available upon the request. So the biggest principle that everybody needs to follow right now is we need to be proactive about security in general, and that's what underlying principle of shift left security means. You do it as in the software development cycle. You do it as far left as possible, and introduce security in layers in every single stage of the process. That will, it's always a lot better to fix things right ahead of time, to be proactive, and then translates into savings later, because 3-4 years down when you're, hopefully not being breached, but going back into fixing the legacy code is very, very expensive. Anything we want to do to help security, especially security of our application, is a good thing to do, right? So building security from the get-go is if we don't do that, then we're doing something wrong. So when we were trying to think, how do we generate threat model, we had to start from the diagram, right? Like, how can we generate the diagrams? And we came up on PyTM, and it will proactively generate your threat model, but you have to pass a whole bunch of stuff to it. It's very manual. We were trying to build some libraries around it. That took a long time, and it just did not work out. And that was like 3-4 years ago when Raj and I were working together on the same team. I was leading a DevSecOps team at a big insurance company. So we were just growing the program from the inception, because as any big company, security is always an afterthought. It's always deliver the code as fast as possible. But then they started getting breached and started being more security conscious. So we didn't have the capability to do things end-to-end at that time. 2 years ago, ChatGPT was sort of a watershed moment where, and then subsequent development of Gen AI really like turned on the light bulbs and said, why don't we just use Gen AI for threat model generation end-to-end? So this is how the idea was born. Is evolution of several different things and seeing things in the wild and see how can we address it using Gen AI. All right, Raj, it's your turn.
Right. So as we said before, right? So how do you do threat modeling on shift left? So for a cybersecurity person to do a threat modeling, they need to have lots of information, right? What's an application, right? The details of an application to start with, right? Then the architecture of the application itself. They need to know all this information to generate the threat model, right? So why can't we start with GitHub? Because it has all the source code. When you provision all the resources using Terraform, we have that information. So the whole idea is to use AI-driven, right? So analyze the GitHub, which has all the information. Basically, take the Terraform in the GitHub. So ingest that into the to the system, and then we use that, and then we generate multiple components out of that. So one is the application details itself. It explains, right? So based on the Terraform, we're able to see what type of components and resources are being used to create an application, right? So we can build that. We can create a graph based on that. So we know what exactly the application is, right? And what type of resources it's being used to spun up, and what CSP, cloud service provider, it's being used. Is it on-prem? Is it cloud? Right? So what type of users? So we'll be able to get all that information there. So to start with, so we're going to use that as the basic input, right? So we read the repository, and then we take the Terraform, and then we ingest that into an agent. So previously, without this, there is a manual effort which we have to do. Right? So a person have to go to the Terraform, get that information out, get the architecture diagrams, and then use that information, all that. So now with these agents, what we can do is we can silo this into a complete orchestrator pipeline, and then we can ingest that information, and then we can go from there, right? So the system which we built is based on two principles, right? So it's good LLMs, we can use it. LLMs has a lot of good knowledge, which we can leverage, but again, LLMs has its own problems, right? It's cognizant deficient, the context window is very small, the memory is short, so there are a lot of problems which we need to keep in mind when we actually use the LLMs, right? It's not simply asking a question to an LLM, so we need to tell the LLM what exactly we need, right? So that's the core principle which we used. So that's the second thing, which the principle is the reasoning itself, right? So how are you crafting the prompt? And then when you ask an agent, what's the prompt you're giving? So the approach we took was a structured prompt. Right? So instead of giving a simple prompt, we are using a lot of information, so collecting streams of information and then crafting that based on the agents which we have. So and then we built an agent called as prompt orchestrator. So what it's going to do is it's going to use that information from multiple streams and then craft a prompt, and then the prompt is given back to the LLM, right? So that's where it's structured. We're not telling them what to do, we're actually giving the information, right? So if we go to the next slide. So these are some of the challenges and then what the problems it can solve. It's a continuous learning architecture because we constantly will be able to integrate into the pipelines within the GitHub repositories or the GitHub Actions itself. That way, if any changes are happening on the Terraform on the fly, we'll be able to get that information and then feed it back to the system, right? So that's why it's a constant learning process, and we'll be able to generate the threat simulations also, right? We have all the details of an application. We'll be able to generate the architecture diagram of the application. We have components of the application. We will be able to generate the data flows, right? All the threat matrix, the threat scenarios, everything is there, right? So that way we can actually simulate in an isolated sandbox environment, and we can get the modeling out. So one of the agent is real-time threat feed integration. So we also created an agent, which we are calling it as an Intel Fusion. So what it's going to do is we're going to feed multiple streams of information from MITRE, right, CWE, all different kinds of frameworks like NIST, CSF, all that is fed into this agent. So the agent is going to put that and augment that, and then it's going to use and then feed it to the orchestrator to build on top of it. Right? So we are calling it as TerraThread. So the protocol which we used is A2A protocol, and the framework we are using is Google ADK. So the good thing is that you can also use the MCP servers, right, which is the current thing here. So there are a lot of MCP servers which are available, which we can actually leverage. Of course, there are certain security risks to that, but having controls in place, so it's adding a lot of value to that, right? So for example, so if there is no diagram, we only have the Terraform available in the repository, so we need to generate a diagram, right? So which we need to analyze. So AWS has released this MCP server, which we can use. There is a tool to generate the diagram, so we can use that and then generate the diagram, right? So similarly, the MCP server also have checkoff integration, so we will be able to analyze the Terraform code, and if there is any misconfigurations, we can get that information also, right? So there is a lot of additional information which we should be able to get using these tools by integrating it to the system, and that way we will be able to feed that back into the system and then keep it learning and then generate more accurate and precise threat models. So we go to the next slide. So these are different types of agents and the roles, right? So we'll start with the ingest agent. So that is the first agent. It's taking the ingestion from the repository itself. So currently we are using GitHub integration. So what we are doing is we give a repository name. So we ingest all the information in that. So here one of the security practice which we are doing is instead of directly integrating the GitHub and then ingesting that into an agent, we have to clean it up, right? So since we are more focused on Terraform or any ISA related files, so only those related files will be used. We clean it up, and also within the IAC there might be some comments which we'll have to leverage. So we clean it up and then we ingest that. So once we ingest, then we send it to the inside agent. So it's going to identify all those entry points, boundaries, and then data flows. This is where it's getting really interesting, right? So this is the information which is really helpful to build that threat model.
Is this all like a sequence going up from down to, it's basically a pipeline of handling the...
Yeah, it's kind of a sequencing, right? So it starts with ingest agent and insights, but in the middle there's a prompt orchestrator, scenario agents. Those are in loop. Right? So because we have to do reasoning and then if we have to do a continuous learning, so it loops into this. But think it of as an orchestrator pipeline. So it starts with an ingest agent, it moves to an insight agent, and then it goes to the validator agents, right? So validator agents is where we put some checks and balances there. Okay? So we look at the patterns, what types of descriptions, all the security practices which we wanted to implement. So we cleaned up, everything is done in the validator agent. So it's clean, so we don't feed directly to the LLM, to prevent all these prompt injections, all that. And then it goes to the simulator agent. If you can
sorry.
Yeah, it goes to the simulator agent. This is where the PyTM, is being used. So previously, we can integrate PyTM into the pipelines, right? So there is a PyTM which you can do, but if you need the model file in order to create the DFD diagrams or the output. So how do we create a model, right? So how do you create a model file? That is where the challenge is, right? We can simply integrate into the pipelines and let the developers run it, but we don't have that model file. So when we are actually working and then implementing in the solution, the developers does not have that knowledge. When we ask them, how they are asking us, please go ahead and create a model file for us, right? The developer does not have that information. So with this AI, what we are doing is we are feeding all this information to the LLM, and the LLM is giving back to the model. Again, we are doing a crafted prompting, so we get the model accurate. And then we do have the generator, so the simulator agent which is actually generates the pi model, it simulates the threads, it executes the threads, and then it gives the outputs. It generates all the DFD diagrams, sequencing diagrams, everything what we need, all the artifacts which we need to further do the threat modeling analysis, right? And the Intel agent, so this is the fusion which I talked before. So it's gonna integrate all these different frameworks of the feeds from different streams. So we started with MITRE, CWE, OWASP top 10, and then OTX, alien.
Imagine how safe your application will be if you go through all these, right?
Yeah, it's a big list.
So think of everything, right?
Correct. So the key thing is sector-specific controls, right? So every organization will have their own set of controls, right? So we can get the information what we have available in the open community, but each organization has its set of controls and policies. So that makes a lot of difference when we actually integrate into the organization level, right? At an enterprise level, we can feed those controls and policies back into the system. That is making much more intelligent than what we have. And the prompt orchestrator. So this is where we need to reduce, because LLMs hallucinate, right? So we need to reduce that hallucination. So in order to reduce the hallucination, we need to do that structured reasoning, and then we need to craft a prompt and then tell the LLM what we want instead of asking the simple question, right? So we feed all that information back to the prompt orchestrator. So the prompt orchestrator will have access to different types of threat templates. It has all different types of prompt templates, threat templates, all the glossaries, all the additional information which we need. So the prompt orchestrator will take a decision on whether to use the existing template because it has all the necessary information, or it's going to build that template and then build that prompt, which is being fed to the downstream agent. So next is the scenario agent. So this is where it generates all the threat scenarios, right? So now with this information, so with this information you generate the threat scenarios. We can ask the LLM, simply and saying, instead of give us all the threat scenarios for this piece of code, right? That's not how it works. So we can craft in a way that, okay, so I analyzed an IAC, I have an S3 bucket, which is public. It has a personal information, PIE. It is a financial service, and the organization has PCI compliance, right? So we can feed all that information, and based on that, the scenario agent will generate all different types of threat scenarios. It's a real world threat scenarios which we can generate using the scenario agent. And then everything is fed back to the matrix agent. So this is where we will be able to map different kinds of threats. So we can generate threats based on stride, we can generate threats based on MITRE, and this agent is gonna matrix everything back and then create that threat matrix. So one of a simple example is, so in stride, there can be the privilege, right? So we can use that and then we can say, is there any threat or a tactic or a technique within the MITRE, right? Which we can use as an initial access. So we can combine both the privileges and then the initial access within the MITRE. And that is much more complex than simply saying, okay, this is stride, this is MITRE. The matrix agent actually fuses everything back and gives that holistic view of combining different frameworks. So, and then we build different types of agents on the reporting side. So we have code advisor agent, we have reporter agent, we have advisory agent. So the reporter agent is basically combining everything and then creating a template, and then a report which has all this consolidated information. But the code advisor agent is what actually generates the mitigations which the developer can actually use and then fix within their code.
Can we generate a Jira ticket to the developer with the suggested fix?
Yes, that is exactly what this code advisor agent is going to give, right? It's going to output and then clearly say, this is a piece of code, this is an S3 bucket, this is the misconfiguration which you missed, this is how you do it, and this is the threat scenarios, and this is the tactic and this is the tactic which you can use, and that's all being given the information to the developer. And yes, we can create Jira tickets.
It also helps developers start thinking about what are the problems, right?
Exactly.
And how to mitigate them. And once then they get really good at it, they can recognize them. You don't even need this thing, right?
Yeah, exactly, right? So yeah, the junior developer does not have this knowledge, right? But we're actually training the developer also and then giving them, the language which they understand, right? So that way they are also empowered, and then when in future, again, we are monitoring all these Git commits. So in future, when they create an S3 bucket, they know this is a misconfiguration which they have to include. So it's safe, right?
Yeah. And we're looking to integrate this into CI/CD pipeline. How long does it take usually for all this pipeline to go through?
So currently it's taking 30 seconds.
Okay.
So we're trying to bring it down to 10 to 20 seconds, right?
That's
So 30 seconds is fair because we are constantly learning, then we are constantly feeding that information to the LLMs, to the entire system. So the time is actually coming down because it does not have to reorchestrate the prompts, right? So it's learning itself and then it's saving the prompts. So we are crafting the prompts again and again. If it's known Terraform or if it's a known IAC, so it does not have to go through those agents. So that's where it's saving the time. So the initial scan time may take 60 seconds, but the subsequent scan times in the same repository can be within 10 seconds.
Right. Next slide.
Yeah. So yeah, this is a prototype. Yeah, we wanted to demo, but we have some technical issues, so we couldn't demo.
So we already talked about this part, right? Because, but these are the goals behind the idea of putting it in one place, so you can understand what drove us to build this application. So, why can't I go anywhere?
Yeah. So this is this is architecture diagram. So you can see. So the purple one is a basic layer, so where it's getting all the ingestions and it's generating all the information which we need. Like the components, the data flows, everything. The architecture diagrams, everything is done on the purple layer. And then the middle layer is the intelligence stream, where it's feeding the information from multiple streams of information. And then the prompt orchestrator is also using there, right? So everything is fed in that middle layer. And then we have the red layer, which is actually the threat scenario agent, and then the matrix agent. So the threat scenario agent is actually generating all those threat scenarios, and based on the threat scenarios, the matrix agent is creating that matrix for us. And then the bottom layer is all the reporting, so the code advisory reporting, or the reporter agent, the advisory agents, and we can build multiple agents depending on the role. Let's say a network security person wants their own set of rules and mitigations, right? We can create a network security role agent, or a cloud security agent. We can create a role, right? So based on different types of roles, we can create all those agents. That way, we don't send everything as a consolidated report. We actually give them a tailored information back.
This is all deployed on Bedrock, right?
Yes, so this can be deployed so as a Bedrock, but the good thing with the system is you can use your own LLMs, right?
Right.
So since it's built on ADK, it's an open source framework, so you can connect your own LLMs, so you can leverage Anthropic or IBM's or Granite, or you can also use the Bedrock's LLMs. So yes, so you have the orchestrator there. The good thing is the orchestrator have access to all these types of tools, and we are also connecting the MCP servers. There's a lot of tooling here. So the biggest difference is we need to understand, do we need an agent or the tool itself, right? There are lots of tools which we're doing, but the agents are much more sophisticated than a simple tool, right? If a task can be done simply by a tool, you don't need an agent. So we simply use those tools. There are a lot of tools which have access here, but a tool which cannot be doing the task, then we use the agents. That's the reason you see a lot of agents doing here. So yeah, as I mentioned before, right? So the core architecture is based on grounding, because it hallucinates. We need to keep it grounded, and in a sense we need to lash on the AI. We need to keep the AI on lashed. So we're doing by doing the structured reasoning. So the whole idea is we need to mirror how the human is doing today, right? So if you go how the human is doing the threat modeling, so we are trying to simulate and then mirror the same using the system. Exactly, they're trying to simulate, yes. Yeah. So if a human is doing it takes weeks, because they need to collect all this information, and it's not seamlessly integrated into the pipelines. Right? We are bringing down that to 10 seconds to 20 seconds. That's a significant improvement using the systems.
Next slide.
So again, that's the threat fusion, which is collecting all the information from multiple streams, and these are some of the sources which we're using. And again, the sector-specific feeds is the key here, because that is actually, if the organization is willing, they'll be able to feed their own controls and policies as a separate feed. So that way, a financial threat model can be different from a health sector.
Yeah, you can have a specialized.
Specialized, exactly.
Right. All right, so this is what we're planning to build coming up. So full GitHub app integration, access to so we can trigger it via CI/CD, enabling GitHub actions. So we'd like to. I mean, you can just tell that there's so many possibilities with this system, and it's almost like magic. You can fit in. You can do correlations, you can integrate it with other security tools, and you can just take like even command line output from a CI/CD and run it through the agent, and to identify, even check the tooling that was integrated in the prior steps. So. The possibilities are really endless. The one thing to watch for is the cost, obviously, with the Gen AI and API-driven pipelines. But I think, the AI is going from being cloud-based now to going back to on-prem, because they want to be close to where the data is. So there's a lot of different trends, and that cheapening the AI. I mean, it's
one thing the system we try to do is optimize the number of calls we actually made to the LLMs, right? Because it's expensive to make a call. We really need to have a justification in order to make a call to an LLM, right? So there's a lot of pre-processing and post-processing which can be done, and then we can keep learning on them and use the existing learning information in order to instead of making multiple calls to LLM. That makes it less cheaper and faster.
Yeah, I'm really thinking about maybe switching. You can switch the Bedrock with NIM.
Yes. Each agent can be connected to its own LLM, right? So the whole point is each agent will have access to multiple tools. So I can have 10 agents, and then 10 agents can be talking to 10 different LLMs, right? So I can use open source, the SaaS-based LLMs, but there can be a sensitive information which I'm not willing to send the information to that, right? So I can use my on-prem LLMs to pre-process those informations.
Yeah, and another thing I'm thinking about is also how do we implement caching so we don't have to do API calls all the time.
Correct, yeah.
Especially the ones that have been done similarly, because if you, in an enterprise, you're going to have a templated code that every application almost has the same kind of problems, right?
Correct.
So caching is very important now. So we're going to keep working on this and developing it. Now, demo time, there's no demo time because we have no Wi-Fi where we're going to demonstrate and use some of this time for this. But we do have an artifact that we have generated through this.
So this is a consolidated artifact, right? So the last agent, the reporter agent, is going to build everything into this report. So it's an artifact which can be shared, but there's a lot of information which we can segregate and then use different types of integrations and then send that information.
Just 1 second here.
Like for example, a developer needs to have those information within their pull request, we'll be able to do that. Or put that into a security tab, we'll be able to do that.
Let me just go here and I can open it. There you go. No, this is not it, right? Do I have it? No. There it is, the report.
We'll have to...
I've opened it, so let me see where it's supposed to go here. Oh, there it is. Raj, you want to do it? It's like showing 2 different screens.
Yeah, this is one of a modeling report, right? And we can have different types of reports here, but just for demo purposes, I included everything into a single report. So you can see, to start with, it has a description. So the description is being generated based on the Terraform code. There is no application description. No one has given that information. So all we are getting this is basically reading the repository itself. So we read the repository based on information what we have. We will be able to generate this description. And we are also using all this information in that orchestrations and then generating the Terraforms. So here we're giving that metadata, how many Terraform modules are there, what types of resources are there within the Terraform, and this is the list of modules which are being used, and this is the list of resources which are being analyzed in that Terraform code, right? So you'll be able to see all these S3 buckets, different types of public access block resource types, IAM, all different types of resource types which are being used in the Terraform. And then once the analysis is done, we are giving the total number of threats, how many high risk, medium risk, and then the straight categories. Then the threat analysis, currently we are using Stride and then CI Triad. These are the two frameworks which we used, and we'll be able to see that information here, right? So how many belongs to the elevation of privileges or information disclosure, and also the confidential and integrated availability here. And we have this table of contents. So this is where we'll be able to generate the threat scenarios. So on these threat scenarios, you can see the severity of those threat scenarios. And again, this is based on the prompt which we crafted and then gave it to them, right? So based on the sector, right, like a financial services or a health service, the risk can be different from one organization to the other organizations, right? The severity cannot be the same. So if it's critical for you, it might not be critical for me. It can be low for me because I don't use those services anymore.
It's customized to your industry, right?
Exactly. So you'll be able to see the risk, all the information here, what threat scenario is, again the Stride and then the C impact, the MITRE tactics and techniques, and then the remediation plan. So the remediation plan and the Terraform implementation, right? So these are the two things which the developer would like to see. They don't care about what's Triad, or if it's an elevated privilege, or if it's an initial access, or if it's a MITRE tactic. They don't care. All they need is, how do I fix this in my Terraform code? This is how you implement, this is how you create the resource, this is the configurations which you have to include within your resource when you're actually creating the resource type, and this is how you do that. Right? So we're giving this tailored information back to the developer. We can do in multiple streams, create a Jira ticket or put those within their pull request. When a pull request is created, you can initiate the scan and then put that within their pull request. Right? They have it handy and they can create those within their pull request. So this is one of the template, and it also provides all the recommended tools and security policies which they can leverage for this threat scenario to work. So yeah, different types of threats. So based on what we have, but that's the a simple template. So it dynamically generates this based on the information we get from the upstream agents. There are different types of, here's for example, a source IP address is spoofing, so it's confidential. In the case of CIA, it's a spoofing. And then you'll be able to see the MITRE, it's a defense evasion. You'll be able to see, if you employ AWS WAF, and then it gives you, the ACL on what we need to be doing in your Terraform code, right? So we're just starting with Terraform, but there is CloudFormation, there are a lot of different types of frameworks which you can use, and then it completely supports those.
So this is threat modeling from the infrastructure as code point of view?
Yes.
We're not doing, going into the application, but we can see how the application is deployed.
So we can start with IAC, right? But if an application team can give that additional information, right? So they might have a separate folder where they're saving all these business workflows. So you can feed those information also, right? So this is like, there is no information available for the threat modeler to create a threat model. All they have is access to the repository. And then we are trying to implement the system and then get those information out and then create those seamlessly in real time.
So are we able to feed the information to it that exposes the risk of the asset? For example,
yes.
Like if you integrate into GRC, you should be able to pull that information and then even prioritize.
Correct. If you have a CSPM product type, a cloud security posture management, we can feed those information back, and we can use that information, and then we can also give that information back and say, okay, you have an alert created in your cloud posture, so how do you fix that? Right. So at the end of the day, the fix have to be going to the IAC if they're using IAC code.
So that would determine the severity of the
yes. It will help you triage, right? Because there are a lot of alerts, right? There are hundreds of alerts. This will also will help. So we can also send all this information for downstreaming and then for pre-processing, right? That way in downstream you have information from CSPM, right, which is your cloud security posture management, or if you have a runtime, which is coming from your workload protections or from application security and the threat models. And again, you have different scanners also, which is doing for SCA, software composition analysis or secrets. So there's a lot of information which can be correlated in the downstream information, right? So if you have a SOC tool, you can feed this information to the SOC tool also, which will enhance and then help the triaging and then fix those alerts.
Now the great enhancement would be to put all the findings into the database mapped to the same application, so you can see how the development team has been patching the threats.
Correct. So we can monitor each and every commit. Right? So we have the history. So we'll be able to generate a pattern and see, okay, is the developer fixing those? Is the shift left is actually happening? Right? Because we need those metrics. So what's the point in scanning within the pipelines? We need to have that metrics going on, right?
Right. All right, now this is all we have for today. Now, anybody has any questions?
Yeah. So the orchestrator, again, the orchestrator is also using a prompt, right? The orchestrator has that information. Yeah, ADK, Google ADK, yeah. Google ADK, A2A protocol, MCP servers. These are the main behind the scenes which we're using. Yes, we have risk scores, and then we're also doing the scoring based on, and we are also adding penalties, right? So we are constantly learning, and then we are adding penalties. So that way, if the penalty goes down, the score of that agent also goes down. If it uses a, feedback mechanism, exactly. So you're looping back, and then we are trying to, make it better and better, right? So prompt A has a score of 50, and prompt B has a score of 40, and then we recraft the prompt, so we get a better scoring. Again, the scoring mechanism is also based on different principles, right? And those also will need to be updated, right, constantly. So it's always a continuous learning process. The more and more you train, the more and more information you have, the more and more prompts we'll be able to generate, and then we can relearn, like the reinforcement learning, right? So that's been implemented, yes, for the scoring mechanisms.
Any other questions? Anybody wants to think of any enhancements, what we can do better? We don't. Unfortunately, we didn't have Wi-Fi to demonstrate the
demo. I mean,
yeah, but
the initial demo was the different ways which you can initiate the scan, right? So we are building a platform also, so you can integrate your GitHub directly into the platform and then onboard all the repositories and then initiate the scan from there, or you can include within your GitHub Actions or GitLab. So any CI/CD we should be able to integrate and then have these scans in place.
Yeah. All right. Well, thank you very much.
All right. Thank you.